Hi, my name is Sharon. Welcome to my YouTube channel where I will cover topics that I'm going over in my classes so that when I'm reviewing or studying, it's just a little bit more easier to grasp these topics in preparation for like finals and things like that. So today what I'm going to be covering is object-oriented programming in Java. Now, did I say that right? A topic. Okay, well, the subject is object-oriented programming in Java. Let me get that right. And then the subject that I will be talking about today is inheritance and overriding methods in inheritance. Now, first to start out, what exactly is inheritance? Like, what is this phenomenon? Okay, given that you know what a class is in object-oriented programming with Java, um, inheritance is basically when we take the attributes of something we called a parent class. Say this would be our parent class, our vehicle with its instance variables, instance var, instance variables, constructor, method, and other methods. So we take these attributes and methods and we implement them into a child or a subclass. Not a child, a child class, a subclass. This class that we are ripping, plagiarizing from is known as our parent class or our superclass. Here we have our subclass, as you can see, car extends vehicle, vehicle being our parent class. Um, this is mandatory. Every time we are declaring that we are inheriting certain qualities from a class, we write public class, um, subclass, extends, superclass. And then we have our instance variables that may be added to our extension of this class. And finally, to construct this new class, um, here we have our signature. We have to implement super parentheses, semicolon, okay? Just to kind of indicate that every time we construct a car, it's going to have, or it's going to inherit the attributes present in the vehicle class. All right, so here is our constructor, and then here would be our extra methods. Method. I will explain this in just a little bit. Okay, so now that we have gotten through what exactly inheritance is, in Java, this is something that's specific to Java. Each subclass can only inherit one superclass, okay? Meaning that this subclass can rip off of this class or another class or like an airplane class or whatever. It can only rip from one though. This is specific to Java. Okay, now some things to kind of mention for overriding. Method overriding, I need to define it first. Okay, so method overriding is basically taking an existing method from the parent class or superclass and rewriting the body of that method um, to change the method execution for the subclass. Okay, so here I do that. I take the method public void go and I rewrite it here. This is mandatory. This at override signifies that this will take over the old method. Okay, so at override, and then I rewrite the body. Here it says the vehicle is going. Here I say bname plus is going. Bname being the brand name, bname, or the brand name that is, hmm, interesting, interesting. This really should say brand name. Brand name. Oh, that's sloppy. Oh well. Um, but basically, this just says brand name is going. So like Volvo is going. It's just being the body is rewritten to be a little more specific to the to the to the class that I'm working with, right? So that's what overriding looks like. Now, there's a couple key things to mention when you're trying to override a method in Java from a superclass. These things I will go over now. So access level can be made more accessible, but it cannot be made less accessible. So here we have public void, oh, public void go, public void go. Okay, the accessibility is pretty much the same. Say this were a protected method instead. So instead of public, we would probably just put like nothing or something like that. Um, then we can't take a protected class and then make it private when we're overriding it. Okay? We cannot do that. We can make it public. Okay? So we can only open up, we cannot close back in. That being said, we also cannot override private methods. Now, the way that I rationalize this is that a private method is classified as private, which means that it can only be accessed um, from the class in which it resides. Now, when we extend off of the parent class and say that parent class has a private method, we're not like reaching into the class every time that we have a car, right? So what car is doing is basically it's just like copying. It's just kind of like ripping from the vehicle class, and then it makes a new class from like the little bits and pieces and like the blueprint that it got its little grubby hands on, right? So when we try to modify a private method within the extension, we can't do that because we don't reside in that class directly. The only way that we can change a private method is from within the class that the private method is written in. Okay? That's the way that I understand it and that I rationalize it. Now, final methods cannot be altered. I think that is just it's kind of like a given. The same thing with final variables. I mean, okay, static methods cannot be overridden either. However, they can be hidden. I'll explain this. So, just to kind of have like a brief like overview of what happens, right? Say we have a superclass instance method. So what does this mean? An instance method, this would be an instance method. Public void go is an instance method. Public int get wheel is an instance method. Basically anything that isn't a static method will be an instance method. Okay, so superclass instance method, and then we try to override it using a subclass instance method. This will override the original method. Okay, a superclass static method. So we have a superclass static method, like public static void honk. And then we try to change it with a subclass instance method. Say like I try to rewrite honk so that it returns um hmm, so that it returns a number like 2 or a string. Maybe it returns a string saying like F you, like because we all get road rage, right? I returned the string instead, and then I print it out later for some reason. Um, so that would give me a compilation error. So I just can't do that. Like I think this follows the basic principle that um, return types also have to be the same for each of the methods that you override. Now this changes in Java 5.0, and it has to do with That has to do with covariant return types, where basically a return type is changed. Basically, the return type of an overridden method is a subtype of the parent's return type. It gets a little complicated, so I'll cover that in a different video. But here, yeah, it just gives a compilation error. Superclass instance, sorry, superclass static method with a subclass instance method. You simply cannot do that. Like, it has to be static in both cases. All right. So superclass instance method, subclass static method. This will also give us a compilation error. You can't just make it static just for the hell of it and overwrite it like that. Um, the logistics behind that, I'm not quite sure exactly why that is, but you just can't do it. I think it has to do with like return types. It has to be the same return type, like I said. Okay, superclass static method. If we try to override it with a subclass static method, what happens is a phenomenon called hiding. Now, this is a little interesting to me because it's not actually an attribute that is useful as far as I know. I may be wrong. I may correct myself in the future. Um, but hiding is basically where you rewrite the static method as if, or you're overriding the static method as if you can override it. So say I put like at override public static void honk, and then I put system.out println. What would you do instead of honk? Say someone's bothering you and they're in front of you, they're going too slow. I don't know. You can replace it with whatever you want. Up to your imagination. Say you want to replace it, right? You rewrite it here. You try to override it. You call upon it here using super dot. Say it would be, what would it be? Super dot honk or something, right? And you call it in the main. It will refer back to this parent class, to the super class. It will not give a shit about what you wrote for the overridden version of that static method. Now, why is that? Why? Because static methods are resolved during compilation time while you're writing your code, okay? So the minute that you run your code, the static method is already embedded in the runtime if you call upon it, okay? So it's already resolved in compilation time. So syntactically it would be correct, you can write like an override for a static method. However, it just will not refer to the static method that you rewrote here. It's just going to refer to this one. Yeah, I guess it's the reason why they call it hiding is because it just kind of looks like you're calling from here when you're just looking at the code and you're not looking at the execution, right? You call upon this, right? It's just going to refer to this back here. When you actually run it. And I guess that's why they call it hiding, because to the untrained eye, it's like, oh, I'm calling it from here, but you're not. That's it. That's pretty much it. That's what hiding is. Okay. Now, to invoke an overridden method, it would be super dot the overridden method. Here it's go, and then any argument variables that go here, and then this semicolon. Um, and yeah, that's pretty much it. I mean, yep, that's it. That's my video. All right, peace out.